So today we're going to take a look at riding a roller coaster and how that applies to section 3.2, which is all about Extrema. So first thing you got to do, think about a roller coaster. Think about your favorite roller coaster. Where is your favorite roller coaster? All right, so here's ours. We're going to start here. Here's our roller coaster, and it climbs. Remember how you get the pit in your stomach because you know that the down's going to come in just a minute, and then it's down, and then it goes up and down, and up and down, and up and down, and up and down, and then finally you get to the end of the roller coaster. So, how many hills does the roller coaster have? And all of these are going to be, we're going to make some approximations as we do this, as we look at this situation. So we're going to approximate quite a bit, which means our answers could vary a little bit, but we should be in the same hood. So how many hills does your roller coaster have? Well, hills. Here we go. 1, 2, 3, 4, 5. There are 5 hills. What is the highest point on the roller coaster? All right, well, let's find that first before we go to question number 2 of that. Highest point. So I'm looking, where's the highest I climbed to? Highest I climbed to is like right in this neighborhood, right? Before I do the downward swing. So I'm going to estimate that to be, I'm going to give it a coordinate. 1500, that's here, my x value. And my y value, if I come over here, I'm going to say it's 75. Maybe, let's see. Maybe 80, right? 1, 2, 3. So maybe 80. All right, so what's the highest point on the roller coaster? The coordinate 1500, 80. And it says how far from the start of the roller coaster does the rider reach this height? So how far have you gone? And you've gone 1500, the units are feet. So to answer this is 1500 feet. And then it says, okay, question number 3, what's the lowest point on your roller coaster? Well, all right, I'm looking at my picture. This is pretty low, but does it go any lower? That's almost close to the same. Here's a lower. Oh, which is lower out of these two? Probably this guy over here, right? This is my low point. And so if I'm looking at where that is, I'm going to estimate that to be about 3,900 because it's just shy of 4,000. And the y value to be, it's not quite 10, it's maybe 7, something like that. Again, estimations. So what's the lowest point? 3,900, and we said 7. How far from the start of the roller coaster does the rider reach this height? Well, here's the start over here at 0, and we went 3,900 feet. That's how far from the start. And then it wants to know for question number 4, I'm not going to show, I'll show you the answer after I write it, but I want you to be able to see the picture. So where's the longest in linear feet drop on the coaster? So which one is the longest drop that you have? So if I'm riding, coasting up here, I get to this point and then I go, woo, all the way down here. So if I look at this, this is pretty long stretch compared to this one, this drop, and this drop, or this drop. So the longest drop goes from this coordinate, 1580, down to the bottom there. And the question is, where's that? So where is the longest drop in linear feet on the coaster? So let's say we went from 1500, the top, and we said that that coordinate was an 80. And then it goes down to just past 2,000-ish. So around 2,000, maybe 2,050. And the y value there, I'm looking at my y value, go across, is about 20. Maybe not quite 20, we're like maybe 15. So that's my highest point, my top point to my bottom point. So where is the longest drop? Between these 2 points. How long is the drop? Well, that's how long is asking you about the y values. What's happening with the y values? So it goes from 80 feet of height down to 15 feet of height. And if I subtract them, I get 65. The drop is 65 feet. All right, if I go back to my picture, next question says, number 5, where's the shortest drop? All right, so I want the shortest height difference. So that would probably go from, I'm looking across my graph, this point to this point. The shortest drop, right? If I look, this is a taller drop, this is a taller drop. This is pretty short, but it kind of evens out. It's a little longer on the tape there. So my shortest drop would be that one. Now again, I'm going to estimate my points. I'm going to estimate that that's about at 2350 with a y coordinate of 45. No? Yeah, 45. That's my top. My bottom down here, I'm going to estimate that to be about 2650. And I'll show you my numbers in just a minute. I know you can't see what I'm writing. To a drop of about 15. Okay, so if that's the case, here's my two coordinates, where the top of that hill is, where the bottom of that hill is, and the question is, how far did you drop? So you went from 45 feet to 15 feet, you dropped 30 feet. All right, well, where is the longest hill? The longest hill, well, I'm looking, I've got choices. These are all pretty tiny hills, right? They're pretty tiny. The big hill is this guy. He's my longest hill. Woo! He starts at 0. Well, actually, yeah, he starts, well, the hill actually starts kind of in this neighborhood here, right, where it starts to increase. So the hill, it's flat here, and then it starts increasing. Let's say that it increases around 350. So we're going to say from 350 feet, and then I've got to figure out where the hill stops. Where the hill stops is what we said right here, right? This is where the hill stops, down at this place. So how long is the longest hill? And we said that this was about 2050. So to 2050. All right, there's the first page. Now let's apply it kind of into one more question on the roller coaster, and then we're going to apply it to section 3.2 real quick. So how high are the cars at the start of the coaster? Well, you can see they're here. This would be a value of 10, so I'm going to guesstimate this to be about 7 feet off the ground, which kind of makes sense, right? Normally when you get on a roller coaster, you're on it on some kind of a platform. And then at the end of my roller coaster is over here. And at the end of the roller coaster, that's pretty much flat on the 10, on the 10 hash mark there. So 7 feet. How high are the cars at the start of the coaster? And at the end of the coaster, I don't need a 2 there. At the end of the coaster, they're at 10 feet. All right, so then the question says, let's apply it to what we're talking about in section 3.2. Let's take it to the pre-calc place. If you're an absolute maximum, you're the highest point overall on the whole graph. So where's the highest point overall on the entire graph? And we said in our work that that was at this place right up here. And we said that that was 1500 for my x and an 80 for my y. So what is the absolute maximum height? Well, the maximum height, here's the height of the coaster, is 80 feet. And where does it occur? It occurs at 1500 feet, when you've gone 1500 feet on the roller coaster. So the maximum height is 80 feet. Notice that that's the y value. The lowest point overall, well, the lowest point we took from the question number 3, and we said that the lowest point was down here, right here. And we said that that was around 3900 with a y value of 7. So what is the absolute minimum height? The lowest this thing goes is 7 feet. And where does that occur? At 3,900 feet, when you've gone 3,900 feet on the roller coaster. But then there's things called relative maximums and minimums. And that's a high point, but it's only a high point in its little neighborhood. It's not a high point overall. See the difference? These guys were the highest point overall, the lowest point overall. They're called the absolute maximum and minimums versus the relative maximums and minimums. And the relative are just high points in their area where they're located. So there's several of them that are maximums in this particular picture. So I look at this one. If you're an absolute maximum, you're also considered a relative maximum. So our first one, what are our relative maximums and where do they occur? Let's talk about where they occur first. The first maximum point I come to is that 1500, 80. All right, it's going to be hard for you to see these and write them. The next one I come to, here's my next hill, it's where the peak is in my picture, and I'm going to say that that is about at 2350 with a height of real close to 50, so 45. And then the next hill I come to is this guy. I might as well put these coordinates here so you can see what I'm writing. 2350, 45. The next one I come to is here, and I'm going to say that that is at just shy of 3,000, so 2990 with a height that is a little bit more than 50, so 52. Again, these are estimations. Then the next one I come to is here, that's the next hill, and that guy I am going to say is at maybe 3,600. And its y value is a little bit more than the last one, so we're going to say 55. The last maximum, relative maximum, it's a maximum in its little neighborhood, and that guy happens at about 4250 with a y value of 40. All right, so going back to number 10, what are the relative maximums? They're whatever the y values were. So I started writing them, but I also put them up on the picture. Our y values were 80, 45, 52, 55, and 40. And where they occurred were the points that we just put on our picture. I'll finish this out so you have the completed answer right here. 2990 was 52, 3600 was 55, and 4250 was 40. So they're in their neighborhood, in their area, they are the highest points overall. And then the last question is asking, what are the relative minimums? So they're the lowest points in your picture. And they're not the lowest point overall necessarily, it's just all the low points, all the valleys. So if I go back up here and I find those coordinates, again, I'm going to estimate these. This one is a low point, that's a minimum, a relative minimum. I'm going to say that that's at 2050 for my x and 15 for my y. Here's my next low point, a relative minimum. That's at 2650 and 20. Again, these are estimations. Here's the next one I come to. That's at about 3350 with a y value of 10. And then this is an absolute minimum that's there, and that one is at 3900 and then 7. Now this one over here is a little bit interesting. Is it really a valley? Is it really the lowest point in its neighborhood? And it isn't, because it keeps constant, it goes constant on you. So that's not considered a minimum at that place. It's just where the valleys are. So going back to number 11, you had what are the relative minimums? That's all the y values. My y values were 15, and these are all in feet. I guess I should have put that up with these guys too, feet. Then it goes 20 feet. I'm taking the y values from the coordinates that you just wrote, 10 feet and 7 feet. And then I want to know, where do they occur? They occur at the coordinates that we just wrote on our picture, 20, 50, 15, 26, 50, and that's 20, at 33, 50, and that's 10, and then 3900, and that's 7. All right, almost done. Then they want to know, where is this thing increasing and decreasing? Now, increasing and decreasing is stuff that we've talked about before. I want to put the picture down below so you can see it. So remember, when you're dividing up increasing, decreasing, you want to know where the y values are going up. So increasing intervals or y values, they increase, they go up. And for decreasing, it's where your y values decrease, go down. I guess I shouldn't use increase in an increasing definition, right? Where the y values get bigger. How's that? And where the y values get smaller is decreasing. Okay. So first thing I'm doing, I'm riding on my roller coaster and I'm going up, right? So I'm increasing from 0 till I get to this x value. Remember, you're writing the x value, but you're looking at what the y's are doing. And then it's decreasing from this x value to this x value. So I'm going to come down here to my decreasing part. And it is decreasing from 1500 to 2050. And then it's increasing again, right? Going back up between these two, between 2050 and 2350. Now I'm here. Now I'm decreasing from 2350 to 2650. All right, I'm working my way up again, 2650 to 2990. And then I'm going down again on my roller coaster, 2990 to 3350. Now I'm down here, I'm going back up, 3350 to 3600. And then I'm going down again from 3600 to 3900. This is a lot. Then it's going up again from 3900 to 4250. And then I'm going down again from 4250 to the end, till here, till they want to know increasing, decreasing, because then it's constant at the end there. All right, so it stops probably about here, which is 4800. So 4250 to 4800, which, by the way, if we're counting this, we're counting this to be the constant part, we probably should go back and do our constant part in the front. So we should count this as starting to increase right about there, maybe at 350. So I should change this 0, because it's constant in that beginning part, to be at maybe at 350. All right, so there you go. That is roller coastering and maximums and minimums. Give a shot to these guys. See what you think of 14 and 15. If you want to pause for a second, I will give you a chance to try them. And then I'm going to give you the answers real quick. So the absolute maximum. Now, absolute means over all the graph for the whole entire thing. And this one's just a little different because it goes to positive infinity and negative infinity. So the absolute maximum, the highest it ever goes to is infinity, and the lowest it ever goes to is negative infinity, but you can't tell me what those values are because they keep changing. They keep getting bigger or smaller. So there are none. There are no absolute maximums or minimums because they go to infinity. But there are relative maximums and minimums. If I look at my graph, here's a valley. That's a minimum. Here's a maximum. Here's a hill. So those coordinates are going to give me a relative maximum. Yeah, it's the biggest point in its neighborhood, but it's not the biggest point overall. And this is the lowest point in its neighborhood, but it's not the lowest point overall. So in this case, I'm going to look at my maximum. I'm going to take the coordinates of what these are going to be, and I can see that the maximum is this guy, 0, 6. And the minimum is this coordinate, -6, -3. All right, increasing, decreasing. First thing it does is goes down, so it's decreasing from negative infinity to this x value of -6. Then it increases from -6 to 0. Again, I'm using the x values. And then it decreases from 0 to infinity. So there's your deal for this guy. And the last one, is there an absolute, like, overall high point on this? And there is, right here. And that coordinate is 3, 2. It doesn't ever get higher than that. If I look at my absolute minimum, it keeps going lower and lower and lower because it goes to negative infinity. So there are no absolute minimums. Is there a relative maximum? Well, he's the high point in his neighborhood, and since he's the absolute, he's also a relative. So 3, 2. Is there a relative minimum? Is there a valley anywhere? And there's no valleys, so this is another none. It is increasing from negative infinity till I get to 3. And it is decreasing from 3 the rest of the way. All right, there's the whole take on the intro to 3-2. So join me for notes next time on class. See ya.